Okay, please excuse the poor quality of this video. The camera itself has limitations to 640 by 480, and I'm having some difficulty in getting it right. Anyway, this is the turntable I built for use with my spectrometer. Basically, I've got a Arduino board in here and a stepper controller. I've got a stepper motor through a gear reduction which rotates the table. The gear reduction is and set up, basically it's 80 steps for each division, and there's 12 divisions. I have the thing set up so it steps to the next position, and then I also have it set up so that if I give it a command to return it home, that it will back up until a magnetic sensor picks up a magnet on the flywheel, stops it, resets the position to 0. That way it's always accurate. Anyway, manual operation of this, as you can see, it's working. I put this switch on to provide manual operation specifically for loading samples onto the turntable. This is set up so if I flip the switch to the left, it sends a signal to advance to the next position. If I flip the switch to the right, it goes back to the home position. And then once it hits the home position, it backs around so that all the backlash is removed. This is a part I made to focus light from a small area of less than a centimeter in diameter into the fiber optic cable which goes to the spectrometer. It does a really good job, and it does seem to provide more light. This is my UV hood. Turn on the white light on it. But it has both shortwave and long-wave UV, and it's 40 watts of shortwave and I think 40 or 60 watts of long-wave. Anyway, this is made to fit inside the UV hood, and that way I can easily load samples, rotate them around, have them lined up so that when they're in front of the sensor, they are also set at an angle where they have the maximum shortwave and longwave exposure. I'm going to stop this video for a second so I can put it back together and show that operating under computer control. As you can see, I have the Stellarnet software, the older Excel spreadsheet opened up. It's been modified considerably. There are going to be more changes. There's a lot of things in it that aren't necessary for the work I do, so I'm trying to hack them all out. Anyway, I have this thing set up for a detector integration time of 300. I usually run at 30,000 because the fluorescence that I'm looking for from chert is very weak compared to what you'd normally expect, and it's rather hard to detect. I also have this which fits underneath the eyepiece when I'm doing the tests, and everything's lined with flat black paper and so forth to reduce the amount of noise in the system. The data page is modified. I've taken some of it out. I've left it set up so it'll take the sample and then it will generate the graph. And I'm going to be taking a lot more out of there at a later time. I really don't need this very much. It's just useful for testing. Sheet 2 is basically where all the data shows up. I have things set up so it generates a nice spreadsheet. You can just copy and paste this from one from this into another spreadsheet once it's done scans. The sample ID, the first page, or the first sheet on here, has a place for 12 different sample numbers or names, one for each position on the turntable. I've got test 1 through test 5 in here, and basically I've got it set up so when you start scan, it moves on to the next sample, and then it switches pages. I also programmed in, it rings a bell every time it's finished with the scan. It's very useful. And once it's done, it comes back to the 0 position, so you can remove samples and start off with position 1 again. Basically, that's what I have working right now. You can see a little bit of my shop here. You can see one of my scopes, counter. I've got a couple of relay actuators and DAC controllers set up so I can do experimentation, laser power meter. Over here I've got more RF related equipment. Anyway, that's basically what we have.